At this point, we're going to use the cleaned and transformed dataset for modeling. When approaching any type of machine learning problem, there are many different algorithms to choose from. Machine learning algorithms are described as learning a target function that best maps input variables to an output variable. The performance of different machine learning algorithms strongly depends on the size and the structure of the data. For the purpose of our project, we will use a linear regression model which is simple to understand and can be very valuable for business decisions. Also, we will use binary classification, which falls into the domain of supervised learning since the training dataset is labeled. Linear regression is a statistical model used to predict the relationship between independent and dependent variables. More specifically, regression analysis helps us to understand how the value of the dependent variable is changing corresponding to an independent variable when other independent variables are held fixed. When working with linear regression, our main goal is to find the best fit line. That means the error between predicted values and actual values is minimized. The best fit line will have the least error. In machine learning models, we are often required to convert the categorical, meaning text features, to its numeric representation. The two most common ways to do this is to use label encoder and one-hot encoder. It is true that most of the algorithms produce better results with numerical variables. Label encoding in Python can be achieved using sklearn library. sklearn provides a very efficient tool for encoding the levels of categorical features into numeric values. In our case, we are using the label encoder to do a transformation from categorical data to numeric data, and we use the fit.transform function to transform the account currency, RBA grade abbreviation and scorecard columns into numeric. In order not to confuse our model into thinking that a column has data with some kind of order or hierarchy when we clearly do not have it, we use one-hot encoder, which is a representation of categorical variables as binary vectors. Now that we have numeric values into our dataset, we are ready to use the linear regression method to make predictions. In our case, we have multiple predictors and the target variable, which is the RBA value. From sklearn model selection, we split the dataset into training and tested subsets, 80% training, 20% testing, and we select a random state of 42, which is a random number that helps to reproduce the same result after the use of the train-test split. Next, we import Spearman from SciPy Stats. SciPy is a Python framework which contains open source packages for mathematics and science. We use SciPy in order to get the correlation between predicted and observed values, both the train and test datasets. The Spearman rank order correlation coefficient is a non-parametric measure of the monotonicity of the relationship between two datasets. The Spearman correlation does not assume that both datasets are normally distributed. Like other correlation coefficients, this one varies between -1 and 1, with 0 implying no correlation. In our model, Spearman rank correlation was 0.78 for both testing and training data, indicating a strong correlation between predicted and observed values.